Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today, for exam P on probability. A family buys two policies from the same insurance company. Losses under the two policies are independent and have continuous uniform distributions on the interval from 0 to 10. One policy has a deductible of 1 and the other one has a deductible of 2. The family experiences exactly one loss under each policy. Calculate the probability that the total benefit paid to the family does not exceed 5. So let's denote by X and Y the loss amounts covered by the two policies. The first one having a deductible of 1 and the second one having a deductible of 2. Then the total benefit paid to the family is 0 if X is less than or equal to 1 and Y is less than or equal to 2. It's X minus 1 if X is more than 1 and Y is less than or equal to 2. It's Y minus 2 if X is less than or equal to 1 and Y is more than 2. And finally, it's X minus 1 plus Y minus 2, which together adds up to X plus Y minus 3, if X is more than 1 and Y is more than 2, so that both losses are above the deductible. Then the benefit paid is less than 5 if in the first case 0 is less than 5, which of course it is always. So always whenever X is less than or equal to 1 and Y is less than or equal to 2, the payment is less than 5 because the payment is 0 then. Then when X is more than 1 and Y is less than or equal to 2, the benefit paid is less than 5 if and only if X minus 1 is less than 5, so that X is less than 6. Then for X less than or equal to 1 and Y more than 2, the benefit paid is less than 5 if Y minus 2 is less than 5, which is the same as Y being less than 7. And finally, when X is more than 1 and Y is more than 2, the benefit paid is less than 5 if X plus Y minus 3 is less than 5, which is the same as X plus Y is less than 8, or equivalently you can write this as Y less than 8 minus X. So as I said, the first condition, 0 less than 5, is true always. So the total benefit paid is less than 5 always in the region where X is less than or equal to 1 and Y is less than or equal to 2. The second condition gives benefit less than 5 when X is less than 6, X is more than 1, and Y is less than or equal to 2. The third condition gives benefit less than 5 when Y is less than 7, X is less than or equal to 1, and Y is more than 2. Finally, the last fourth condition gives benefit less than 5 when Y is less than 8 minus X, as I said before, or minus X plus 8, so that we can see that that's the area below the line where Y is equal to minus X plus 8, which is a line with slope -1 and y-intercept of 8. And the second condition is that X has to be more than 1 and Y has to be more than 2. By combining all of these conditions, we can graph the region where the total benefit paid to the family does not exceed 5 in the two-dimensional graphic showing the area where the joint density of X and Y is positive, which is, well, X is uniform between 0 and 10, Y is uniform between 0 and 10, so the joint density is positive for in that region where X is between 0 and 10, Y is between 0 and 10, so it's a 10 by 10 square. And we have uniform distribution because they're independent and they're both uniform. So we have uniform bivariate distribution, and that tells us that we can calculate probabilities by comparing areas. And here is that picture. We have the 4 regions all together. They're marked with these dotted lines, and it's 3 rectangles and 1 triangle, and these are the 4 regions where the conditions 1, 2, 3, and 4 are met. So these are 4 regions where we have the payment less than 5, does not exceed 5. And what we need to find is the area of the region marked with dotted lines as a fraction of the whole area of the 10 by 10 square. And we can find it by just finding the area of those 3 rectangles and the triangle. And you can in fact very quickly calculate that. The 2 rectangles at the bottom together have the area of 2 times 6, so that's 12. The vertical rectangle from 2 to 7 has the area of 5 times 1, so 5. And the triangle has 2 perpendicular sides, each of length 5, so it's a half of 5 by 5 squared, so its area is half of 25, which is 12 and a half. So altogether, the area is 29 and a half as a fraction of 100. That's the probability of what we're looking for, or that's the probability we're looking for of that event, that total benefit paid does not exceed 5. And that's, of course, 0.295, which is answer C. Please remember, this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.